Okay, so welcome to our physics class. Today we are going to deal with, we continue our topic on pressure. And our objective in today's class, our objective in today's class is to derive the formula for calculating pressure due to liquid column. So this is our topic in today's class. We want to derive this formula. But for us to derive this formula, I will refer you to the previous lesson. We had said that for us to calculate pressure, we know that pressure is given by force divided by area, because we know that a pressure is a force perpendicular per unit area. That is what we said last time. Pressure is a force perpendicular per unit area. So how can we derive the formula? Let's say that we have a container, and our container has got a base. So assume that we have a container. And this container has a base area. This is base area A with a height, and this height is h, and it has got density, liquid density, and this liquid density rho, we represent density with this notation called rho. So how now can we calculate the volume and the mass of that container? Before we talk about that, let me draw that container, because it's going to be a cylindrical container. So let's say that we have our container here. Let's say that we have our container. This is a bit smaller. This is our container. We have our container. This is what we have as our container. This container that we have got the liquid columns inside filled up. It is filled up to the brim, completely filled. This is the area of this container. This is the height of the container, which is represented by h. The height of the container is h. This is the height. Of course, this container is being placed on a table. This is being placed on a table. This is our table. So this container is a cylindrical container. It is cylindrical. This is a cylindrical container, but we know that there is so many things acting on this container. That includes the atmospheric pressure. We also know that even the container itself have got its own mass, and we are interested in the volume of the liquid column that is inside the container. the liquid column. Because for you to derive the formula for calculating pressure due to liquid, you must refer to this container. So let's start by saying the volume of this container is going to be given by the area multiplied by the height. So it is area multiplied by the height. Then what will be the mass of this container? The mass, we know the mass is nothing but the volume multiplied by the liquid density. So it is volume multiplied by the liquid density. So this is what you have got. Now that we have this, our mass, therefore, we know that volume is given as area multiplied by height. So our mass now is going to be area multiplied by height multiplied by liquid density, which is given as rho. So this is where you need to start. But remember, in our previous lesson, we had talked about the difference between mass and weight of an object. And I told you that a mass is nothing but an amount or quantity of matter in an object. So it is a measure of matter in an object. So it means that for us to calculate or to derive the formula for calculating pressure, you need mass, you need volume, and then we need the weight of that container. But we know from the definition of our last class, we know that weight is given by mg. That is what we said. Therefore, what this implies is that weight is equals to, our mass is no longer m, is now area multiplied by height multiplied by rho. So what you have here is area multiplied by height multiplied by rho, then multiplied by this g, which is acceleration due to gravity. Are we together, class? So this is exactly what we are supposed to do when we are deriving the formula for calculating pressure due to liquid column. So now, I will refer you to our equation 1. This is our equation 1, which is the formula, general formula for calculating pressure. So what we have here, which is the weight of that object, is nothing but the force. This is the force. So what this implies is that the whole of what you have here is nothing but the force. So our P, which is pressure now, is nothing but, instead of putting force, we are going to put this. So we are going to have the area multiplied by height, multiplied by rho, multiplied by acceleration due to gravity, divided by area. Here we've got two areas, so this we cancel this. So our formula, therefore, is P is equals to height, rho, and acceleration due to gravity. And this is the formula for calculating pressure due to liquid columns. So in our next video, we are going to apply this formula in problem solving. For more information, you can tell me what you think on the comment section. See you in our next class.